GE is a 124-year-old startup, and GE is going through a transformation. They're becoming a digital company. I work out in San Ramon. I'm the head of mobile engineering. From oil and gas, power generation, wind and water, rail cars, wind turbines, builds power plants. The industrial internet is going to quickly catch up and outpace the consumer internet. This is why GE is all in on this. In this part of the IoT world, this industrial internet of things, we're talking about major assets, oil rigs, rail cars. So these assets are all getting smarter. They're getting more and more sensors. There's an explosion of data. How do you use the data to keep the assets up and running longer, less downtime, to increase their lifespan, to avoid major disasters like a blowout of an oil rig? Working with these assets, one major part is servicing them, a mobile workforce. So this mobile workforce needs applications that are always on, top of a wind turbine. In a rail yard, you're working on very complex assets. You need information about those assets. There's a whole platform being built called Predix. Getting that data from these assets, getting them into the cloud and running analytics, you can dispatch the mobile workforce to service those assets. You can go out now, Predix.io. There are services out there like Machine, which is about how do you connect to these machines out there. Edge Manager, managing these devices remotely, like time series, asset data, data services. What we built is a platform as a service really designed to build these industrial mobile applications, both hybrid and native. Talks to a back-end service that's running in the cloud, connects to some back-end system. Industrial internet mobile applications they're mission critical, they have to work everywhere, and they're always connected to some enterprise system. Multi-tenant and it's cloud-based. Easily spin up back-end service that could be a cluster of Couchbase nodes. Highly availability that's replicated across data centers. It doesn't require you to have an IT organization to manage that. In our next release, great service, Predix Mobile HA, you say, I want 3 servers and 2 gateways. On our SDK, we let you build applications across all the major platforms. We build in the offline support. Couchbase comes built in the SDK. It runs both hybrid and native. So you can extend the services. This is showing an example of a camera service. You call it as a RESTful service. That'll activate the camera and let you take pictures.
So this is just a quick demo I threw together. HTML, JavaScript, CSS is resident on the device. Go into airplane mode. I can still navigate my application. What if I'm a field engineer and I actually want to log in? Well, that's a problem. I can't do that. Here we are, I've pushed an update, and now I have a screen asking me to create an offline password. So that into airplane mode. So now it's asking me for my offline password that I just created. And I'm into the application. I can see my data. I can see network connectivity. My data changes will sync.
In an offline first, it's a lot about the data. You need the right data at the right time. We invite you to go check out Predix Mobile.
So my name is Aaron Benton. We're here to talk about rapid data modeling and testing. I am a Couchbase community champion. I work as an applications architect for Market America and Shop.com. I primarily work with the mobile apps team and our front-end UI team. And we chose Couchbase for a variety of reasons, including scale and performance, flexible data model. We're now changing how we think about data and how we structure our data, going from a relational schema to a non-relational schema. And so no matter what your workflow is, data still needs to be a consideration. We all know that this is actually the true project lifecycle. Enthusiasm, disillusionment, panic, search for the guilty, punishment of the innocent, and praise for the non-participants. John Johnson said, first solve the problem and then write the code. Data is a problem that needs to be solved. So we have conceptual, logical, and physical data modeling. In the conceptual phase, all we're doing is representing entities and relationships. We can represent these entities using a variety of notations like function to logical data modeling. Now we've added in attributes. A user has a user ID and a first name. Order has an order ID and has line items. So regardless of what database we're using, we've gone through conceptual data modeling, we've gone through logical data modeling. In a physical data model, in a relational system, it's real easy. There's a lot of tools out there. But with NoSQL, how do you represent your data model? What tools are available? How do you show relationships? Does your code define and document your data model and represent? There's a lot of questions that we came up with and we had to answer. YAML, yet another markup language, but this provided us a more concise way to describe and define our JSON data models. So now what do? We We actually need data to work with. There's actually a lot of good data generators out there, but they all have one fundamental problem, which is relationships are hard. Your orders need to be tied to valid users. So we came up with Fake.It, a CLI tool that's inspired by Swagger. Define our models in YAML. This can generate JSON, CSON, CSVs, and export data to Couchbase. If I was having problems with a Nickel query, I'd say, hey Brent, here's what my model looks like, and send him a simple YAML file without actually providing him my real data. A truly randomized data set in this case, which is not only good for my application developers, it's also good for my UI developers. And actually output it to a CSV file that then could be imported into this relational system. I just generated 1,000 documents and threw them into Couchbase in less than a second. We added Sync Gateway support to Fake.It. We have dependencies. We have definitions of a phone number and an address. And phone is going to be referenced here as a home phone and then a work phone number. We need to be able to deal with existing data. There's a separate GitHub repository out here that's Fake.It examples. The social data set actually has a lot of really good Nickel examples. The flight data one is probably my actual favorite data set. Airports and runways and users and airport reviews, airport navigational aids, or what airports are within 100 miles of a given airport. You can actually do all those things in Nickel just like you could do in a relational system, be performing complex Habersign queries.
Hi, my name's Dave Starling. I'm the CTO of CNIT, which is a London-based company research. So it was founded about 2.5 years ago by our founder, Emily Forbes. We provide a new production model for companies like Rolls-Royce, Red Bull F1, and it's a new way of doing internal communications videos. So it's anything from internal comms videos to branding, broadcasting, marketing, and fan engagement. BT Sports fan pundit program, Rolls-Royce, where we have a mobile app. We use that to capture content. So they will ask their community to shoot some video. And that gets sent into this online studio, designed to be managed by a non-technical person. We can also share those clips out in a feed. All of this is managed, all of this is run on Couchbase, using Nickel, key lookups, or using full text search.
Are you filming?
Using CNIT today.
Solidarity with refugees.
I'm a nature photographer.
What inspires me to capture the night sky.
Training time.
One step closer to Rio.
Come on, Wales! Keep watching.
Exposure, the focus, stability, audio noise, all things that we might want to be able to derive from video. Can we understand what they're saying, and are we interested in what they're saying? So Google's machine learning platform includes a number of ready-to-use out-of-the-box processing tools for audio content and image content, as well as textual content. So how do we do that with video? We take a frame grab every second, and then we process each frame grab. Okay, I'm 90% sure there's a windmill in that photo. We can immediately identify that that is an underexposed photo. We can tell if it's stable. Also background noise. How was it shot? So is it a pan? Is it stationary? So we can look at dominant colors, moderate offensive content as well. So we can tell if someone looks happy or looks angry or looks sad. And we can also perform optical character recognition. So if we know that there's some logos, we can blur those out if there are copyright issues. One that we ran with the Red Bull Formula One team. It recognized it was a Formula One car and that there was, it was open wheel, it was a sports stadium. Retail chains to identify when there is stock coming in that is, has been poorly delivered. In Rio, the British athletics team, we can identify individual sports. And then the sentiment analysis. And here he is looking rather sad. Next stage, audio transcription. Further and perform natural language processing. Apply some Nickel to this. So full text search offers a number of things that are incredibly useful for us. So there are several pre-built analyzers. We'll do word stemming. So waterfall will stem to water. A number of different languages support result snippets and word highlights. And then faceting. We actually developed, tested, and released all of those in a week. This is within the BBC Earth platform. And if you search for frog, you would hopefully see lots of pictures of frogs, and you do. In a predictive search, start typing, and within less than half a second, behind the scenes, we've actually performed about 5 different searches, combined all of those results together. I'm going to take a photo. I'm going to take a photo. So that's now uploading into our studio. So there you guys are, and we can see the tags. Hopefully, we've got audience, convention.